New the theorem. If f is continuous on a closed interval AB, or if f has only a finite number of jump discontinuities, then f is integrable on closed interval AB. What does integrable mean? The definite integral a to b fx dx exists. What was integral a to b fx dx? This simply represents the limit. Okay, let's go to the limit definition. This, okay, the limit definition, there you go. Integral a to b fx dx is the limit n approaching infinity, I going from 1 to n, fx I star delta x. So this, remember, each of these products is area of a rectangle, width times height. Summation means take the sum of all these areas. Limit n approaching infinity means take many more rectangles, that is thinner and thinner rectangles, and find the limit of that. That is called your integral. Okay, so when does that limit exist? If f is continuous, that limit does exist. Or if it is not continuous, then it has only finite number of jump discontinuities. What we don't want are discontinuities which go to infinity or negative infinity. That is the infinite discontinuities. We don't want those. What we also do not want are infinitely many discontinuities. As long as you are a finite number of discontinuities and those discontinuities are jump discontinuities, this limit, that is the integral, will exist. Okay, and gives the same value no matter how we choose the sample points x. To simplify the calculation of the integral, we often take the sample points to be the right endpoints. So xi star is xi. So this xi star sample point is xi. So f of xi. What is xi? Xi is your starting point plus take I rectangles worth width. That's what I del x means. 1 del x is 1 rectangle worth width. 2 I del x means after 2 rectangles, the right hand point. 3 del x means after 3 rectangles, the right hand point. So xi means the ith rectangle right hand point. So we are choosing right hand points. So if you are integrable, then you may as well choose the right hand points, okay, which is what we did in many of the examples we saw earlier. Okay, here is an example of how those theorems are used. Express this limit n approaching infinity, summation I going from 1 to n, xi cubed plus xi sine xi delta x. Express this expression as an integral on the interval 0 to pi. All right. So what do we do? This delta x is written dx. Xi cubed, xi sine xi. Simply drop the i's to get x cubed. That should be a plus x sine x. Limit and summation simply is replaced by integral symbol. How do I know these limits? That's given by my interval. That's how you express this as an integral. All right. Do note, I'm unable to fix it on my slide, but if you have a printout or something, this should be a plus, not 1. It should be a plus. Okay. When Leibniz chose the notation for an integral, he chose the ingredients as reminders of the limiting process. In general, when we write this equals this, yeah, so limit and summation put together is that S. Okay, A and B should be given to you in your interval. So these are the limits of integral. Fxi star is replaced by simply fx. Delta x is replaced by dx. Okay. Evaluating integrals. Let's try. How do we evaluate integrals? When we use a limit to evaluate a definite integral, we need to know how to work with sums. The following three equations give formulas for sums of powers of positive integers. Now this is important to know, guys. You may not understand it, so let me explain what they mean. All right, so okay, what does the first symbol mean? It means the following. Suppose n equals 5, right? N equals, I don't know, n equals 5. This symbol means summation I going from 1 to n of I. That means when I is 1, you write 1. When I is 2, you write 2. When I is 3, you write 3. I is 4, write 4. And I is 5. 5 is n. So I'm going to go until 5. Okay. Find its value. Well, that's what the left hand side is. Okay. So I don't know. Let's add these. 1 plus 2, 3, plus 3, 6, plus 4, 10, plus 5, 15. Let's compare it with the formula here. N is 5. So I'm looking at a fraction 5, 5 plus 1 over 2. What is this? It's a fraction 5 times 6 over 2. Well, 2 cancels the 6 3 times. So 5 times 3, 15. Okay, 15, 15, we are fine. You can try this game again. N equals, I don't know, 10. This is simply I again. I'm looking at the first formula again. Formula 5, that is summation I. In other words, I'm doing 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. What will this all be? 3 plus 3, 6 plus 4, 10, 15, 21, 28, 36, 45, 55. Whereas the formula, I'm looking at the fraction. N is 10. 10 times 10 plus 1, the whole over 2, which is a fraction 10 times 11 over 2, which is the fraction. 2 goes in, I don't need a fraction anymore. 2 goes in 10 5 times. 5 times 11 is 55. Okay, so we agree. Now, of course, examples don't prove a result, but I hope you are convinced that this summation equals this formula is a true statement. That is, it will always work no matter what n. We have checked for n equals 5 and 10. All right. But convince yourself that this will be true for all n. It is some work to prove that that's true. Okay. Likewise, the second formula, I'm now taking squares. So say n equals 5. I'm now taking I squared. So 1 power 2 plus 2 power 2 plus 3 power 2 plus 4 power 2 plus 5 power 2. You understand? That's what it means to say summation I going from 1 to n I squared. So you're taking every value from 1 to n. 1, 2, 3, 4, 5. And then what are you doing inside? You're taking its square. That's why 1 square, 2 square, 3 square, and you're adding it. Okay, so this is 1 plus 4 plus 9, oops, plus 16 plus 25. Let's see what's the answer, right? 1 plus 4, 5, plus 9, 14, plus 16, 30, plus 25, 55. Now let me compare it with this formula on the right. It's a fraction. What's upstairs? N, that's a 5. 5 plus 1, 2 times 5, 2 times 5 plus 1, the whole over 6. All right, let's see what's that as a fraction. 5, 6, 2 times 5, 10, plus 1, 11 over 6. Aha, 6 cancels the 6. I have 5 times 11, 55. Okay, so we agree. Likewise, you might want to check for 10. I will not, but I hope you believe this formula. The third formula says cube it, not square, cube. So again, let's try n equals 5, just as an example. 1 power 3 plus 2 power 3 plus 3 power 3 plus 4 power 3 plus 5 power 3. This is 1 plus 8 plus 27 plus 64, 64 plus 125. This is equals 1 plus 8, 9, plus 27, 36, plus 64, 100, plus 125, 225. Whereas my formula on the right is, it is, oops, parenthesis, a fraction. What's upstairs? N is 5, 5, parenthesis 5 plus 1, denominator is 2, and close the outer parenthesis, power 2. So this is a fraction. Oh, I meant open parenthesis. Now 5 upstairs, 6 upstairs, 2 downstairs, close parenthesis, power 2. Okay, so 2 goes in 6 3 times. So that is 5 times 3, 15, power 2, 225. So we agree. So these are the 3 formulae you need to know. Memorize these formulae. They are very useful. Summation I going from 1 to n is n plus 1 by 2. Summation I squared, I goes from 1 to n is n times n plus 1 times 2n plus 1 by 6. Summation I cubed, I goes from 1 to n is n times n plus 1 by 2, the entire squared. Okay, notice the similarity between the third one and the first one, right? But there is a square here. So I cubed, not I squared, mind you. I squared is a long formula. So memorize these 3 formulae, and we will need to use these in our next videos. Okay, until then,